Hi everybody. In this video I'm going to take you through me and Cormac's creative project. It's a little step-by-step tutorial on how everything actually works. So this is Wobble. We named our project Wobble because of the wibbly wobbly sound that it makes. And this is the centerpiece of this whole program. It's the Raspberry Pi 2 that we're using. We're using the Raspberry Pi 2 because it's actually pretty powerful for the size, and we're running C++ on it, and we're running a library for C++ called Maximilian, which is pretty much makes all the sounds. We're also using a couple of other libraries for our sensors. And so yeah, the main thing is this Wi-Fi dongle right here. This makes it so we're using Wi-Fi connection to actually code on the Pi, so we don't have to have any wires for the actual physical coding on it, on the device. And then the other connection to it is this is the audio out, which is a portable anchor speaker, really small but actually really powerful portable speaker that actually so we can actually hear the sound that we're playing. And then the next thing is this, which is actually a rechargeable battery, one of those power supplies that you charge your phone with, which actually gives power to our Pi, so we can actually run the code on it. And then we have the cobbler over here. This is connecting all the 40 Raspberry Pi pins to this cobbler that goes down to our super complicated limited edition breadboard over here. So here the cobbler connects to the breadboard, and then through the breadboard we can actually connect and communicate with the pins on the Raspberry Pi. So all these wires are actually connecting to all our sensors and all the bits and bobs that we use for it. So this is actually two breadboards taped together, so we're actually mounting them together. So the next step is the sensors. We have two ultrasonic sensors, one on the front and one at the top. So what they do, they send out ultrasonic signals and listens for the echo. So by that, so you can actually detect distances using these sensors. And on the top, right up here on the top, over here, is a luminosity and lux sensor, which takes in the luminosity in the room and the environment, so you actually detect how light the room is. And then we have the motor that is mounted in here and goes all the way down here. And this is a 6 to 12 volts 20 RPM DC motor. The original idea was to run this motor through the Pi as well, so we have all the wires from the motor connecting to the breadboard as well. We have a piece of code that actually runs the motor for us, but when we try to add our codes together, there's something that doesn't work. So what we did is a little hack. So we're actually running the motor separately from the Pi, so we're actually connecting it straight to the 9-volt battery, making the motor run on its own. Then the last step is these LEDs we have over here. These are an Adafruit LED strip that is glued onto the centerpiece of the device. And the idea as for the motor is that we wanted to run these strips, LEDs, through the Pi as well. But the problem we have here is because the library that this Adafruit library that these LEDs are running is written for the Arduino. So we wanted to wrap it and try to find different C++ wrapper to actually have it running through the Pi as well. But we haven't managed to get that working. So what we did is that we actually incorporated an Arduino in here. So there's actually another microcontroller in here, which is an Arduino that we also run without a wire. The only wire we have is connected to this battery over here. This is a plastic case holding 4 AA alkaline batteries. But if we have 4 batteries, it will generate 6 voltages. But these LED strips only takes maximum 5 volts. So what I did is that I removed one of the batteries and actually made a little operation here that actually I removed one, and then this wire is connected to the other battery, so everything works. So this generates around 4.5 volts. So now the only thing left to do is actually connect all this together. So we start with connecting the LEDs. So I'm gonna power this up, and the code runs on the Arduino. So as soon as it powers up, the code starts running. So see, the LEDs start flashing, and then we're gonna power up the Pi. So we take the power cable, plug it in, and just mount this down. So what I'm gonna do now is I'm gonna SSH into the Pi and then run our code on it. It takes a little while to boot up. So if everything is connected as it should be, this should start playing. So this is the first sensor, this is the main sensor of the program, which is taking in the distance from objects around it. So when you place an object in front of it, Wobble will detect the distance from that, and depending on the distance, it will produce a specific note. And on the top, we have another ultrasonic sensor that is measuring distance from it, and what that does is actually making a frequency modulator. So and all the way on the top is the luminosity sensor, and that takes in the light in this around it. So if I cover this up, we're gonna hear the sound change. So you can hear distance. So the idea with this is that if you have it in your room and you turn off the light, Wobble will sound different. So we'll take in the surrounding around it and then play different music. And we can have the modulator as well. See if we can. So everything seems to be working fine. So the last thing we need to do now is to actually connect the motor. So we connect the 9-volt battery, and what we do, we just put the top on, and Wobble is now fully operational. So the motor is spinning the whole centerpiece around, and the centerpiece is rested on a Lazy Susan bearing, which makes it easier for the motor to rotate it. So the idea now is you can place Wobble wherever you like. You can place objects around it, and these objects will work as the instrument, and you actually play its surrounding. I will upload a video of Wobble working with a melody playing based on the objects around it, and all the wiring, everything is open source, and you can find everything in the blog post. And I hope you guys enjoyed the video, and yeah, see you soon.